Hi, this is a quick video demo on Tensorflow and neural network application in insurance industry. As a use case, I'm choosing the Allstate Claims Severity from Kaggle competition from back in 2016. In this video, I'm going to show you how I built a neural network using TensorFlow library uh, and then build the model, train the model, and predict the cost of claims based on the claims attributes or the features. The technology stack that I'm using, it's very simple. Basically, I'm running on my MacBook Air laptop. I'm running a virtual machine with a Ubuntu operating system and with Python programming language. I'm also using Jupyter for writing and editing the code or the source code. I'm using scikit-learn. It would be useful for me to develop the basic linear regression for baseline, and of course the TensorFlow library is required to build the neural network model. So very quick, let's just jump to the demonstration here. I installed Ubuntu on a virtual machine with VMware Fusion on my MacBook laptop. So just to show you real quick, this is a Linux Ubuntu 1604, 64-bit desktop version. And it comes pre-installed with Python 3 version 3.5.2. I have also installed Jupyter version 4.2.0 and scikit-learn package version 0.18 and also TensorFlow version 1.4. In this virtual machine, I allocated around 5 gigs of memory out of the 8 gigs that available in my laptop. Also, I allocated the entire 4 cores to help with the processing. Right. So let's start with opening the Jupyter notebook. Right. When you type in Jupyter notebook, it will open up the browser that will allow you to pick the file that you want to use for work. I'm using this one. This is the notebook file that I already used to develop or to write the neural network model for solving the Allstate claim severity problem, right? So in my model or in this notebook, I have 3 sections here. First is the data preparation. So I'm using Pandas library to read the CSV file. Train.csv zip is the dataset file that comes or I can download from a Kaggle competition. And then as I examine the dataset, I'll run it as we go through it. As I examine the dataset with check the head, it will show me the summary of the dataset that I'm working with. And yep, I have 188,000 rows with 132 columns. Now if I check the columns, I have ID and then cat1, cat2, cat3. These are the categories or categorical columns. And then cont1, cont2, cont3, cont4. These are continuous numerical columns. And then I check for if there is any null value in the dataset. It turns out there's 0 null value, so I can be sure that the dataset is clean and I can start working with it. Now, of course, before I'm doing anything, start using the dataset, I would want to make sure that I normalize the categorical data into one-hot encoding and the numerical data into single scale or standard scale. What I'm choosing here is a min-max scaler. And the next steps that I'm doing right here, as we're waiting for that particular block to complete the process, then after I clean up the data, I split the data to 80% training data and then 20% for holdout for testing, right? So I'm using a scikit-learn model selection train test split class here. So here's my data. Out of 188,000 rows, I have a total of 1,153 columns. That's the expanded columns comes from the fact that I create a one-hot encoding for each of the categorical data. And then I have the training data size as much as 150,000 rows, and then 37,000 rows remaining is I'm going to use this for testing. So once I have the data set ready, now the next or the first thing that I want to do before going to the Tensorflow and neural networks, I'm going to run this with a simple linear regression model. I'm using the linear regression class from a scikit-learn linear model. It might take a moment. I'll just wait right here, probably to so what I'm trying to do here is I want to know how the data behaves if I analyze this using the basic linear regression model. This will serve as our baseline. I can tell you right now that the result is not quite good. It's not even acceptable for the competition's submission. It's way the error or the accuracy score is way too far from the submitted scores. It might take a while. I would probably fast forward this section on the final video. My laptop fan started spinning and making noise here. It's kind of indicating it's processing. Okay, now it's done. It's pretty quick, and I also plot the result on the prediction against the true value. I guess the result is kind of all over the place. A lot of prediction that is way far from the true value because this is a linear regression model. So I think this kind of this suggests that the data set is not suitable, or the linear regression is not suitable to attack this data set. And as we can see here, the accuracy score is at 41 billion, accuracy score. The accuracy score is calculated by calculating the mean absolute error, meaning that how far the prediction deviates from the true value. With 41 billion, that's a huge number. Okay, so the next what I want to do is I'm building a neural network model using Tensorflow. So first I import the Tensorflow library. I also use several other libraries such as NumPy and OS library, right? And then what I did in the neural network, when building the neural network model, I start with defining the learning rate and then the batch size and the epoch, number of epoch. I think on the last run, I can get I can complete 10 epochs in 2 minutes, and 100 epochs roughly slightly over 20 minutes with this machine. So first step is reading the data. That's something that's been done above. So I have the DF, actually it's DF train and DF tests that I'm going to use in this model. And the step 2, create a placeholder for X and Y. X is the features, and then Y will hold the regression output. Step 3, I create a topology. In short, the neural network topology that I'm using for this particular problem is I'm using 3 hidden layers. Layer 1, it connects from 1153 features to 256 hidden nodes on layer 1. And then on layer 2, it connects to 128 nodes. On layer 3, I connected 128 nodes to 64 nodes. And on the output layer, I connected 64 nodes to one output node. So it's very simple. And perhaps also worth to mention that I use a sigmoid in each hidden layer. I use sigmoid as the activation layer. And then the step 4 is building the model. Basically is the output layer here. So I just simply call it as regression. It's making it easier for me to keep track of the code. And then step 5, I define the loss function in this case, because what we are interested in is the mean absolute error. So because TensorFlow has a class mean square error, which I can use to approximate the mean absolute error. And also I define the error rate here with streaming mean absolute error. This is for capturing or to calculating the final accuracy score, right? And then I define the optimizer. I use Atom optimizer with the defined learning rate to minimize loss, right? And then this steps is running the model, basically creating a session, and then in that session, I also write or create a summary writer here, and this is to capture the results and being able to present the results on Tensor Port. I do also add an embedding projectors. This is also for visualization. The next thing that I'm doing is initializing the TensorFlow variables. And then this block is the actual training process, right? It will train the model n epochs time at n batches per epoch. So basically I'm doing 10 epochs, and in each epoch I divided the training data set into a smaller batch size and train per batch, right? And the final block here is calculating the mean absolute error with the test data. I'm using, since I already split the data set into training and test data, the test data is being used to measure the final accuracy score. So this is from the last run. I achieve accuracy. I can complete 10 epochs and achieve accuracy by 1169. So let's do a rerun. Just run that, and then from my console here, I can see that there is an information message. This kind of indicating that the TensorFlow library is starting to work. Also, I can start to see that the training is starting, right? And as the training process is starting, uh, we will be able to see the progress from here from a Jupyter notebook because I printed out the uh, at every epoch I printed out the this is the loss value. I can also start run Tensor Port with Tensor Port log regression here and uh, open up the Tensor Port. Okay, the Tensor Port is running. Now I can go back to my uh, Mac and open Tensor Port. Okay, and then we can monitor the learning progress through a Tensor Port. So, okay. Yeah, the first two steps is a bit weird here. Apparently, the learning is going worse. And even worse, it's going up. Let's see, 7. Oh, it's okay. So this could happen because the dataset introduce probably local minima, and then it trying to reach the global minima. Or it could be because the learning rate is too big, so it kind of overshoot the learning and jump from uh, and stepping off of the minimum loss. Now we can start to see that uh, the loss value is starting to decline. This is what we've been expecting in the model. I can give refresh every time. Okay, now we can start to see. Now at step 5, it's starting to learn quite well. And then step 6 is even better, starting to descending to the minimum loss. Okay. While we're waiting for the training process to complete, we can also inspect the graph. Okay, so this is the graph, or this is the network. It comes with it starting from the X placeholder, and the value I pass through the value through 3 hidden layers. Layer 1, layer 2, layer 3, and then being fully connected at the output layer, and it calculated the mean squared error and trying to descend the loss value or the loss function, right? And towards the end, I will be calculating the mean absolute error value to determine the accuracy score that I'm getting from this model. Now let's go back to the loss. So it's starting to learn. It learns pretty quick. I think at step 9, yeah, I think it completed the learning process by 3 minutes. And let's go back to the Jupyter notebook. As we can see here, the measured accuracy score is 1202. This is pretty good. Probably will put me at rank 2000 out of 3000 or 2/3 in the Kaggle leaderboard. I don't know. Certainly further fine-tuning or parameters tuning is required if we're looking to win. But this demo, this is a quick demo that we can use neural network with TensorFlow library to develop a solution or a model uh, for predicting the cost of claims based on the Allstate Claims Severity Kaggle competition. Okay, and then the last thing, as we completed uh, the neural network process or the training process, we can see the graph here from Tensor Port. I can also inspect the distribution values in each layer, also view the histograms of it, and I can also inspect the projector. Oh, apparently it's not completed yet. Model CKPT. So apparently the regression is not showing. Checksum does not match. Okay, the model CKPT doesn't work. Probably I should have deleted. Oh, okay. Anyway, okay. Anyway, to conclude this demo, uh, it's a really quick demo just to show that a neural network can solve the Allstate claim severity problem for a insurance company. And of course, again, as I mentioned earlier, further tuning is required if we're looking to win the competition. The other key takeaways of this is that the TensorFlow is suitable for developing a neural network model, even on a small machine. I'm using a MacBook laptop with 4 cores and 8 gig memory, no GPU here. Training process requires some time, but GPU certainly could accelerate the process. If we're looking to increase the data set or we're looking to extend the number of epochs, then a GPU packed machine would certainly help. That would conclude my demo. Thank you very much for watching.